Hi, and welcome to a very cool game development tutorial. Today we are going to create this nice looking Breakout game, which is created using Apple's SpriteKit, and you're going to win this game if you hit all of the bricks, and you lose when you hit the bottom of our screen. And let me also mention that if you're looking for some more basic stuff, like the basics of Swift development or creating universal apps using Swift and iOS 8, then you can just see two courses that I recorded recently, and you will find their UDEMY links in the video description. So now let's going to get deeper into this game, and before we get started with coding, let me show you some of the basics of SpriteKit. So let's have a look at the SpriteKit world, which is actually a world of physics. Every world that you will create will have some standard physics applied to it, like gravity. And this causes every object that you create, like a ball or a circle, to respect this laws of physics, like the gravity, which causes the ball to just fall down. So every object that you create, so every node in terms of SpriteKit, has a so-called physics body, which can be either static or dynamic. If it's static, then it won't respond to the physics, and if it's dynamic, then something like that happens. So let's have a look at this video. We have a ball here, and this ball bounces off of the borders of our screen, and this is due to the settings that we apply to it, and it's dynamic. So a physics body can have a shape, a density, a friction, and many more properties. So let's have a look on how to identify objects. So in each game you will have different kinds of objects, so like a orange and a blue dot, and when we talk about our Breakout game, we have our paddle, we have our ball, and we have our bricks. And we have to distinguish between those objects, and we can do that by using so-called bit masks. And bit masks are integer values which contain a binary number, like this one. And you can see that those two objects have different bit masks. So the first one has the 1 at its last position, and our blue circle has the one shifted one place to the left. And by adding these bit masks, we can actually distinguish between those two objects. And this is a highly important matter when we are talking about SpriteKit development, since we can use that for collisions and detecting when an object touches another, and we can distinguish the objects. That's because it's so important. Like when we want to find out if our ball touches the bottom of the screen to know when our game is really over and when our player loses the game. And this can be done by also applying a bit mask to the bottom itself, where you can see in this example where the 1 is again shifted one place to the left. And these are some basics that we're going to use when creating our game. So let's dive right into it and create our Breakout game. To do so, we're going to create a new Xcode project, and this is not going to be a single view application, it's going to be a game. And we hit the next button, and let's just call it Breakout. And we are going to use Swift, of course, and the game technology is going to be SpriteKit, and we're developing this for the iPhone. So click Next, and let's also create that on the desktop. And what we want to do first is import all of our assets. And we're going to do that by just simply drag and drop them. And I've got them here, and you can, of course, also download them. And we'll find them in the tutorial files. We'll just select all of them and bring them to our image assets folder. And we can also import the background music. I will just simply add that here. And also select this copy items if needed when it's not checked, and click finish, and then we're ready to go. So we're going to start by working a little with our game scene Swift file. And first of all, what we're going to do is remove all that dummy code. So let's do that. You can Also remove the update function here. And we're going to start by creating some categories for our game. And these categories we're going to define just at the start of our class, and these are going to be constants. So let's first give our ball a category name. So a ball category name, which is going to be as simple as ball. We also need the pedal category name, which is simply pedal. And we're going to give our bricks a category, which is the brick category name, which is going to be brick. Since we also want to listen to some background music, which sounds like that, let me just go ahead and play that for you. Boom. And so on. So you get the idea. We are going to need a music player, an audio player, and to use audio, we are going to need the AV Foundation framework, which we are going to import right at the start here, just below the import SpriteKit statement. So let's import AV Foundation. And this allows us now to create an object, which we're going to call background music player, and this is going to be an AV player, AV audio player. So now we are ready to create our first function, which will be an init function, which we are to simply override the init with size function, and we also need to state the override here, and also we need to call the super init with size and tell it which size it is. And we also need to init with a coder, which is going to be required, and also call super init coder a decoder. All right, now we shouldn't get any errors anymore, and now we can just start by creating our music player. And therefore, we first need to define a URL for our music file, which is in our project. And since this is kind of easy, let's just call this bg music URL. And we're accessing the NS bundle, our main bundle of our application, and simply ask for a URL for a resource with a name and extension, and the name is bg music. And the extension is MP3. So this will allow us to play this piece of music. And now we will set up our music player using, again, an initializer, the constructor AV audio player, with contents of URL, which is our bg music URL. And we don't need an error here, so we simply assume that this is going to work. And now we have to define the number of loops that we're going to play this song, and since we want to run this song indefinitely, let's just say -1, which states that this should run in a continuous loop. And now we need to prepare our music to play, and now we simply play it. Background music player.play. But before we are going to test this, we need to make some adjustments to the game view controller. So let's click on the game view controller here, and what we want to do is actually remove the contents of the view.load method, and instead of using the view.load, let's use view will layout subviews, which is a better place to initialize our game scene that we have got from the template. And what we do here is we call the super view will layout subviews. And what we want to do now is we want to create an SK view, which is our view itself. So let's say self.view, not view will layout subview, and cast that to an SK view. All right, now we have to check if this view exists. So let's say if SK view, basically it's seen, we're asking if it's seen exists. If this is nil, then we need to create a new scene. And this is actually our scene, our game scene. So let's say skview.showFPS, which shows the frames per second, which is quite useful sometimes. So let's set this to true, and also skview.showNode shows node count, which is also quite useful. And now let's create our scene, which is our game scene. And this is the game scene class with the size, and we're simply using skViewBounds.size, and we're doing this in view with layout subview since we don't know the exact size of our view in view.load. We know this in view with layout subviews. And now let's add a scale mode. So game scene dot not this game scene. It's this game scene with a lowercase g. And now let's state the scale mode, which is sk scene scale mode dot aspect fill. And since we're using Swift here, you could also leave this out and simply write aspect fill. And now let's say skView dot present scene. And of course, now we want to present our game scene. And before we run this application, since this is a landscape game, we have to click on our project here on the top left corner and select or deselect the portrait here in the device orientation so that it only displays our game in landscape left or landscape right. So now let's go ahead and run the app and see that we can hear our nice game music. Now that we have our game music up and running, it's time to add some more colors to our world. So let's go ahead and add our background. So we go back to the gamescene.swift file and add some more code to the initWithSize method here. And we will now define a sprite node for our background, and therefore we create a constant and just call it background. Background image, for example. And now we can just simply say sk sprite node, and we initialize the sprite node simply with an image, and our image is named bg for background. And now we will just have to position this background image. So we access the position property, which is a cj point. So let's simply say cg point make, and the x position will be we will center this to our world. So we simply say self.frame.size.width divided by 2, and exactly the same thing we're going to do with the height, and thereby we center our background image. And now we simply have to add a child to our world, which is self.addChild, and we add our background image. And now when we run our application, then we can see we have our nice looking background already in place. Let me just turn down the volume a little, and there we go. So let's break this, and now we will have to talk about our gravity. As I told you, every world has its gravity set to a standard of the Earth, and we will simply deactivate the physics for now and say self.physicsWorld.gravity will be 0. And since gravity is a vector, we have to say cg vector make, and since there's not since we don't need gravity neither in x nor in y direction, we want to have a gravity. So all right, if we were to position a ball now within our game, so let me just open that up. If we were to, this is the wrong one, so let's run it again. If we were to position a ball now within our game, then this ball would maybe begin moving in this direction or in this direction, but what would happen is that it would get off our screen, since the ball could not collide here at the borders or the edges of our screen, because we have to create these borders first. And we will do that by creating a physics body and add this physics body to our world. So let's say create a border, or let's say a world border. And this is going to be an SK physics body, and we will use the edge loop from rect initializer to use our frame as the border of our world border. And now we can simply say self.physics border physics body equals our world border. Well, that's nice. And now we will set the friction of our border to say physics body dot friction equals 0, so that the ball does not slow down when it touches the border of our world. So now that we have talked about this ball so much, let's also create it also in the initWithSize method. And this is also going to be a sprite node, just like the background itself. So let's simply call it ball and say sk sprite node, and also initialize it with an image, and this is simply ball. And now, since we are going to use this ball sometimes, and we have to compare it with other nodes, we will give it a name, and therefore we have created the ball category name. And we also give it an initial position. So let's say x is the position property, and again this is a CG point, so we use CG point make. And let's say we want this to be at self.frame size width. Also, let's start in the center, or let's start at a quarter of the width, and frame size width height maybe also at a fourth of the height, and we will just adjust that value if we need to do so. So let's add our ball to our world and give it some physics. So as I told you, each object, each node, each sprite node has a physics body. So let's access the ball's physics body and create one using sk physics body. And this time we will use a circle of radius, and the radius is the ball.frame.size.width divided by 2, and the actual width comes from the image itself. So once we divide this by 2, we get simply the radius of the ball. And let's just adjust some more physics, like the friction. So physics body.friction equals 0. Let's now go to the restitution, which should be, as you can see here, determines the bounciness of the physics body, and we want it to bounce off the borders of our world. So we set this to 1, and now let's also access the linear dampening, which is going to be 0, and the ball should not rotate. So let's again access the physics body and allows rotation. Let's set this to false. And if we were to run this now, let's do that. Then you can see there is our ball, but it doesn't move. So let's apply an impulse using also the physics body. Apply impulse, and we will use a vector here, x direction 2, y direction -2. And as you can see, once we apply the impulse, our ball begins to move and nicely bounces off all the borders. And now we can also see, when we do not add this physics this physics body to our world border, you can see that once we started the app, well, you can see the ball is gone. Let's do it again. As you just saw that it switched off the screen here, and since we don't want that to happen, we will activate it again, and as you can see, this works quite nicely. All right, so now that we have a ball and we have some physics, let's add our paddle so that the ball can bounce off this object as well. So let's create a paddle constant. Paddle equals, also this is an sk sprite node, and we also use an image here, which is the paddle image. And also we give this paddle a name, which is paddle category name. And we'd also like to give it a position. So let's say paddle dot position. And now I'm going to show you a little nice method, which is cgrect get mid-x, which gives us, for example, the mid-x position of self.frame, so we don't have to divide it by 2. And let's also give this paddle in the y position paddle frame size dot width dot height, and this height times 2 as the initial y position. All right, and since you can see here, we multiply this by 2, and I'd like to add this now. Add child paddle, and as you can see, nothing happens so far with the with our ball. But you can see that this paddle is here at the bottom, and if you're familiar with iOS development, you know that the coordinate system usually starts in the top left corner, but using SpriteKit, the coordinate system starts in the lower left corner. So this is quite an important piece of information to know how to actually set the coordinates of your object. So let's close our simulator and apply some physics to the paddle. We're doing this the same way we did it before, accessing the physics body, and initialize this with an SK physics body. And this time we again use a rectangle, not a circle, a rectangle of size, and we use the paddle frame size to approximate the actual physics body, the physics body size. And now let's add some physics to it. So let's say paddle.physicsbody.friction is let's say 0.4. Let's add some restitution, which is 0.1, and it is now not dynamic, it's static. And let me not apply this now for a moment. Let's just start the app and see what happens. As you can see, the ball just hit our paddle and it started to move, and this is kind of counterproductive when we're talking about a breakout game. So what we need to do is, let's just do it again because it's so much fun. As you can see, it bounces and the paddle moves. So what we need to do is make this paddle static and saying physicsbody.dynamic equals false. And once we do that, you can see that the paddle does not move anymore once the ball hits it. All right, that's quite nice already. So we have applied the physics, all right, to our paddle, to our world, and what we want to do now is move our paddle around. So we do that by using 3 different functions or methods relating to the touches we can apply. So we will use touches began. We will use, okay, just give me some space here. We will use touches moved, and also touches ended. So I have added all those 3 methods, and we will use some code here that you might already know from normal iOS development. But what we need to do now is also add another property here at the beginning of our class. Let's call this a variable, and we will call this finger is on paddle, and this is going to be false as an initial value, and we will set this to true as we start touching the paddle. So what we need to do first is we need to get our touch itself. So let's create the constant touch, and we will use the parameter touches here and use any object and convert that to a UI touch object. All right, and now we can get the touch location, and this is going to be touch.location in node self. Now we have the touch location, and what we need to do now is identify the body that we have touched, and we need to see if this body is our paddle. So let's create a body object, And this is going to be, and this is important now since we need to be able to make this optional. This is going to be an SK physics body, and this is an optional. Since this can be nil if we click on or if we touch the background itself. And we now say self.physicsworld.body at point. And the point is, of course, our touch location. And since this is an optional, our body, we can simply use an if statement to check if the body, and since it's optional, we have to use a question mark here, and its node and its name is equal to our pedal category name. And if that is the case, then we can, for example, say print line pedal touched, and also we can activate our bool, which is finger is on pedal. This is now true once we begin to touch it. Let's continue with the touches moved method. And since we only want to move the pedal as long as the finger is touched on it, let's ask if finger is on pedal. And here comes the bool that we just defined earlier, quite handy since we can now determine when our finger is on the pedal. And if it is, let's also get the touch again, which is touches.anyObject, and also convert that to an UI touch. And also we want to get the touch location, let's just say touch log, touch.location in node self, and we also want the previous touch location. I just abbreviated by using pref touch log, and we use touch.previous location in node self, and we need to use that to calculate the x position of the pedal. And let's now create our pedal by simply saying self.child node with name. Thereby we get the pedal that is already created in our world. So let's say pedal category name, as this is an SK sprite node. And now let's calculate the new x position. So let's say variable new x position equals, and now we use the pedal, its position dot x, and add the touch location, touch location dot x, and subtract the previous touch location dot x, and thereby we get new x position of our pedal. And now we simply have to access our pedal object, access its position, and make a new CG point with the pedal, with a new x position and the pedal's current y position. And if we run our app now, then we can see that this works really nice. Our ball bounces off the pedal, we can move it around, but what doesn't work right now is that that the pedal does not move beyond the border. And we can simply adjust that by adding 2 more lines of code, and because of that we have defined this as a variable, the new x position. So let's say new x position, and take the maximum value of pedal of the new x position, and the pedal dot size dot width divided by 2, or let's also say this new x position, its minimum is the pedal, the new x position of the pedal, and self.size.width, and subtract the pedal size dot width, and this divided by 2. So using this calculation, we can now run this again, and as you can see, now we can move our pedal more to the left or more to the right than the border of our world. Nice. Now that we have applied all of that to our pedal and to the movement, now you will notice that we can move this around even if we do not click on the pedal once we clicked once. Because of that, we have to implement the touches ended method, and we simply need to say finger is on pedal equals false. And once we run this again, we can see that once we move this our pedal around and we click outside of it, we can't move it anymore. Only if we touch on the pedal, then we can really move it. All right, now let's talk about some new cases for our ball. It bounces off the borders, it bounces off our pedal, but sometimes something different should happen, like now. Actually, when the ball touches the ground or the bottom, then we want the game to be over. And to create this effect, we need to implement the bit masks that we were talking about earlier in this tutorial. So let's create some category bit masks, which we will use to distinguish between the different kinds of nodes or objects within our game. We will start with the ball category. And this is going to be a uint32, and the reason for the 32 is that we are going to have 32 bits that we can use, which means that you can actually have up to 32 different objects and distinguish each object by its category bit mask. And since we're using really the bits itself and shifting the bits around, we have we just write 0x1 and shift this 0 to the left. So this two less than signs indicate that we shift the bit 0 to the left direction. And now let's continue with the bottom category. So the bottom is the area where when the ball hits the game is going to end. So this is also uint32, and again 0x1, and this time we shift the bit with the 1 to the left, and we continue with the block or brick category, which is uint32, and this time again we shift the bit, but not once to the left, we shift it 2 positions to the left. And the last one is the pedal category, also uint32, and again we shift the bit, but this time 3 positions to the left, which means that we get something like, let's say 0, 0, 0, 0, 0. There are actually 32 zeros, but just for simplicity's sake, let's assume these are 32 or 31 zeros. And now, as you can see, we shifted the bit to here, and here the bit is at this position, so the bit is shifted 2 positions to the left here, and here we shifted 3 positions to the left, so 1, 2, 3. All right, now you know how we can distinguish between all the different elements, but we also need a specific delegate, so we adopt the SK physics contact delegate to find out when a contact really occurred. And we are going to go to the bottom of our file and add the did_begin contact method. We won't enter any code here yet, but we have prepared now the corresponding delegate method to the protocol we just adopted. What we need to do first is go up to our initWithSize method again and click here below the pedal implementation and the implementation of the pedal's physics body. What we want to do now is create actually a bottom for our, so let's see here, let me just start this game for a second. So once we hit the bottom, we also need a node for the bottom, and this is what we are going to create now. And first of all, we are going to need a rect for this bottom. So let's say let bottom rect. This is going to be a cg rect make, and we will let this start at the self.frame.origin.x position, so actually at 0, and also self-frame origin y, and it's going to have a width of the whole screen, so self frame size width and a height of just 1 pixel. And now let's create our bottom, which is going to be simply an SK node with no image or anything, just a simple transparent node that we can use to identify a contact with the bottom. So now let's add a physics body to it. A physics body equals SK physics body, and initialize it with the edge loop from rect, which is the bottom rect. All right, now that we have set all these properties, let's add our bottom to our world, saying self add child bottom. And now what we can do is we can add all of our bit masks to the proper nodes. So let's start with the bottom and the physics body and its category bit mask. And this is going to be the bottom category. Let's continue with the ball. Its physics body and the category bit mask is the ball category. Now what's missing? The pedal. Physics body dot category bit mask equals pedal category. All right, and now the ball also needs a so-called contact bit mask so that we can determine when a real contact occurred. So let's say ball.physicsbody.contact test bit mask, and this is going to be the bottom category for now. And later we will also add the brick category in order to find out when a ball collided with one of our bricks. So let's now go back to our did begin contact method, and first of all let's create 2 bodies. This is going to be a variable, so first body, which is going to be SK physics body, and a second body, body equals SK physics body. All right, and what we want to do now is we want to check what which body actually is which. So this seems to be a little complicated first, but I'm going to show you what this means in a second. So let's ask our delegate parameter contact. If contact dot body A dot category bit mask is less than contact dot body B dot category bit mask. Now we know that if this is the case, so if the category bit mask of body A, which is in this parameter here, if this is the case, then we say that the first body is going to be contact.body A, and the second body is going to be contact.body B. Else, it's actually the same thing, vice versa. So first body is in this case contact.body B, and the second body is contact.body A. And since we have given a very good category bit mask to our ball category and our bottom category, the ball category is always smaller or less than the bottom category. So we know that the first body actually is when we have a contact between the ball and the bottom, then the first body is always the ball and the second body is always the bottom. So what we can do now is, since we have assigned those bodies to our variables, SK physics bodies, we can now ask if the first body and its category bitmask is equal to the ball category, and if the second body and its category bitmask is equal to the bottom category, then we can say, let's say you lose as a print line for the moment. We will add another screen in a second. And now let's run our game. And what we should see now is that once we hit the bottom with our ball, we should get the print line, and we don't get it because we did not set the delegate properly. So let's go back to our init method and add the contact delegate. Let's say just here below the super init, and we simply say self.physicsworld.contact delegate, and this is equal to self, since we adopted the skphysics contact delegate in this game scene class. And once we run that again, we should be able to see that yes, you lose. Let's move the pedal around a bit, and you lose again. And now we have a first step toward detecting contacts between two objects. We already did that now for the bottom and the case if the player loses. Now we need to think about the bricks itself and create actually the breakout feeling within our game. So let's go back to the init method, and what we need to do now is create our bricks, and therefore let's first create some constants. Let's say a number of rows. You can just choose what you want as long as it fits on the screen. I'm optimizing that now for the iPhone 6, but you could choose different numbers or optimize the position of the bricks just as you like it. And I will choose a number of bricks equals to 6. So in each row there will be 6 bricks, and let's now determine the brick width, which is going to be skSprite node, and we will simply use the image named and access the brick image and get its size and its width. And let's also determine a padding, which is going to be a float, which is going to be 20. And what we are also going to need is the offset between the left edge of our screen and the first brick. And we can simply calculate this by calculating the actual width of all of our bricks plus the padding that is between all of them. And once we have this red area here, we can subtract it from the whole width of our screen, and what we get as a result, we divide that by 2 and thereby simply get the area from here to here. And this is what we're going to do in code now. So let's calculate that offset. Saying this is an offset going to be a float, and let me just paste that calculation, since it's a pretty long expression. As I said, we are taking the full width of our world and subtract the brick width multiplied with the number of bricks, adding the number of paddings that is positioned between each brick, and subtract 1, since let me just show this to you. We only have 1, 2, 3, 4, 5 paddings, but we have 6 bricks in this row, so we have to subtract 1 here, and at the end we divide this by 2, and we have a float value here. So now we have the offset. And what we want to do now is creating 2 for loops to create all of our bricks here. So actually one for loop which creates all of the bricks for one row, and actually another for loop for each row. So let's begin with one for loop, which is the index in 1 to number of rows. So this is we're iterating 3 times through this for loop, and each time we create a new for loop which then iterates again number of bricks in our case 6 times, to create our necessary number of bricks. And we will now create such a brick, and this is going to be SK_sprite node, and with image named. My code completion doesn't work at the moment, as it seems, with brick. And what we want to do next is positioning each brick. And since this is actually a heavy calculation, which is not so hard at all, but I have figured out that Swift gets really absurd when you type in long calculations. As you can see now, after we have typed in this long calculation, we don't have code completion anymore. I don't really get it, but I've just pasted it here, and what we do is actually simply positioning the brick according to its index. So if we have a look at this again, we're taking the first brick, positioning it with the offset that we have calculated, and adding a padding, and then for the second index we're adding some space here, and so on and so on. And that's all that's behind this calculation. So have a look at it in the code files. It's pretty simple, actually. So let's now move on to the physics of our bricks without code completion. So physics body is going to be an SK physics body. We are going to use a rectangle, I hope of size is correct, block brick.frame.size, and let's build that and see if it works. It doesn't, or it does. All right, let's continue with the with some more properties. Physics body question mark, because it's optional, allows rotation is false. The brick's physics body, its friction is 0, and its name is the brick category name, and brick dot physics body. This is now actually the most important part. We now set the category bit mask to the brick category, and now all we need to do is say self add child brick, and hopefully this works, and I have spelled everything correctly, and it looks good. Now that we have actually our bricks set up and ready, we can also add the contact test bit mask of our brick to the boss physics body, and we are adding a pipe to the bottom category here in this line, and adding the brick category right here. So let's see what we've done. And as you can see, the bricks are actually on the X direction, are positioned quite nicely, and they are also moving around according to the physics. And what they need is the proper Y position, and also they need to be destroyed as soon as they got hit. So let's go back to our for loop here, to our first for loop, and let's calculate a proper Y position. We're doing that by creating a variable, which is a Y offset. And this is going to be CG float, and we simply open some curly braces here and switch through our index. And we can now simply say that in the case of 1, we want to return, let's say, self frame size height times 0.8, and we can now simply copy this line and add that, let's say, 3 times. And there's also the default case in which we return 0, and this is 2, and this is 3, and let's say here it's times 6, and here times 4. And once we run this now again, we should have, not now, let me just stop that again. We also need to add the y offset to our calculation for the position here, to the CG point that we're creating here. So let me now run this again, and let's see what happens. And as you can see, we have our bricks now, and they are moving around. But this is not a big problem, since we are going to destroy each brick once the ball hit it. To destroy these bricks, we will now go back to our didBeginContact delegate method and insert an if statement at the bottom, which is going to be firstBody.categoryBitMask. If this first body is equal to the ball category, and the second body and its category bit mask is equal to the block, the brick category, then our second body, which is the brick, and its node is going to be removed from parent. Well, that should do it. Now let's have a look again. And let's move our pedal around as soon as it starts. And there we go. And the bricks are destroyed. Once we press it, once we touch it. And the problem is that once we destroy all of them, let's just do that, nothing really happens. Or let's not do it, let's reduce the size first. Let's, for example, say we only have one row with 3 bricks. And as you can see, once it runs again, and if I actually hit them, which isn't so easy at all. Come on. Well, as you can see, nothing happened. So we get notified here when we lose, but nothing happens if we win. So what we need to do is actually creating a function that determines if we really won the game. Therefore, let me end our simulation, and let's go below our didBeginContact method and add another function, which is going to be isGame1. We are returning a bool, and first of all, we define a variable for the number of bricks and set this to 0. And now we create a node object in a for loop and iterate through every child. So through every we go for node object in self.children, and thereby iterating through all children in our world. And we are getting a node object for all of them, which is of type any object in Swift, and therefore we need to create another node object which is node object as sk node. And now we can say if node dot name is equal to block to brick category name. What we can do now is simply add number of bricks plus equals 1, and this is really useful because now we can return an expression number of bricks if this is less. If this expression is true, then we have 1. If not, so if there is more than 0 bricks still on the screen, then we will return false through this function. So we go back to our didBeginContact method here and check if is game 1, then we want to print line you win. All right, so let's now run this again and see what happens. So when I am lucky and I hit the bricks, Well, now you see you win, and that's actually all we wanted to see. And we will now have to create a new screen actually to show the user that he won or that he lost the game. And to do that, we will simply click on our game scene Swift, press Command N on the keyboard, and add another Coco Touch class, which is going to be the game over scene, and this is going to be SK scene. Let's create this object, this class here. And now we have this this Swift file prepared, but what somehow doesn't work is that it imports the correct framework. So now we have to replace the UI kit simply with SpriteKit to remove that error here, and we will also create an init with size method here, but we also add the parameter player1, which is a bool, to determine what kind of message we want to display, and we need to we also need to add the init with coder initializer here. So let's just add that, a decoder, and this is going to be required. All right, and here we also need to call super init size, and now we are ready. So also here, let's add our background in this file. So sk sprite node with image, which is bg. The background position dot position is going to be cg point make cg point make now cg rect get mid x of self dot frame and cg rect get mid y of self dot frame, and now let's add self add child background. So there we go with our background. Now let's add a game over label, which is an sk label node with a font named, I have used near black. The game over label, its font size is going to be, let's say, 46. And the game over label dot position is going to be cg point make cg rect get mid x of self dot frame and cg rect get mid y of self dot frame. And if player 1, then the game over label dot text is going to be you win, else it's going to be game over label text game over. All right, now all we need to do is add child the game over label, and one thing that's missing now is touches began in order to get back to our real game once we press on the somewhere in the game over screen. So let's breakout game scene is going to be game scene init with self dot size, and all we need to do is self dot view present scene breakout game scene, and that should do it for our game over screen. And all we need to do now is go back to our game scene, and in the case that in those two cases here you lose, we are going to display our game over screen. So let's remove this this print line here. Let's say game over scene is going to be game over scene init with where is our custom initializer? Actually, we have a size of self frame size and player 1, which is false in that case. This should actually work. And it does. So let's now self.view present scene the game over scene. And now let's do the same thing here again, but this is the view win scene, if you'd like. So this is, well, we called it game over scene, and there it is. The size of self.frame.size and player 1, this time it's true. And now let's say self.view .present scene you win scene. All right, so let's run our game and see if it works. And we have game over. And, well, the game over screen obviously works, but we maybe need to adjust our start impulse that we gave our ball. So let's maybe say 3 and minus 3 as a vector. Let's see how this turns out. Not so good either. Maybe we should position the ball somewhere else. Let's say the ball position is now self.frame size width and always a third of it. And let's go back to our initial impulse of 2 and see if this is going to work a little better. And there we go. Now we hit our paddle perfectly, and once we drop it, the game is over. And now let's see if we add again our number of rows, we had 6 bricks per row, and we had 3 rows. Let's see if this works. All right. There we go. We have a nice little breakout game, which is quite hard actually. Okay, got that one. I won't annoy you now and play this game to the end. I hope you enjoyed learning something about SpriteKit, and I'm sure you can improve this game a lot. So let me know what you did and what you'd like to see next as a tutorial, and have fun creating your own breakout game.